I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic is Nonlinear Partial Differential Equations of First Order, Standard Form 5. We are going to discuss in detail about definition of partial differential equation, dependent and independent variables, Standard Form 5. Partial differential equations. An equation which involves one or two partial derivatives is called PDE. That is PDE. The expansion is partial differential equations. Partial. So the mathematically the symbol is dou. Dou z by dou x. Dou z by dou y. Here the variables x, y and z. In these two, among these three, these two x and y, they are playing the role of independent variable. Coming to the variable z, which is playing the role of dependent variable. So the partial derivative compulsory at least, that means minimum, it should have one dependent variable and two independent variables. Then such equations, this type of the framing it is there, then we will call it those equations as partial differential equations. The notations are dou z by dou x, which is denoted by small p, dou z by dou y, which is denoted by small q. These two are first order and they are represented by p and q. First order linear equation we can tell, because if you are taking this is dou, only dou is there, only one time we are going to do the differentiation with respect to x. So only one time we are doing the differentiation partially. The dou represents partially. So first order, the degree is 1. So first order linear equation, that is denoted by P. And this is also first order linear equation, that is dou z by dou y, which is denoted by q. Whereas this is second order, because we are doing the differentiation two times we are doing. So dou square z by dou x square, whereas coming to the degree which is 1. So second order but linear equation. The notation is R. Similarly, dou square z by dou x dou y, that is also denoted by S. So dou square z by dou y square, that is also denoted by small t. Now, non-linear PDE of first order, that's what we discussed. Dou z by, now dou x, it is there. This is first order and the degree also 1. So first order linear equation. Then what about non-linear PDE? That is non-linear partial differential equation of first order. It's nothing but dou z by dou x the whole square. Otherwise, dou z by dou x the whole cube. This is first order, but the degree is here 3. Here the degree is 2. That is the reason they are not coming under linear. They are called as non-linear PDE of first order. The PDE which involves First order partial derivatives P and Q of degree higher than 1. So that's what the examples. Here in this example, the degree is 2. In this example, the degree is 3. So the degree higher than 1 and the product of P and Q. P, the notation we know it, dou Z by dou X, and Q, the notation we know it, dou Z by dou Y. These two, their product also called non-linear partial differential equations. Now, in this lecture completely, standard form 5 we are going to concentrate. That is, these non-linear equations also we have to find the solutions. How to deal those very difficult non-linear. The non-linear partial differential equation is a challenging task to the engineering field because their physical significance, what the engineering, science and technology, they are demanding. Those physical significances only we are writing in terms of this non-linear partial differential equations. How to solve those non-linear partial differential equations? There are some standard forms are there, and using some methods we are going to solve it. Specifically, we are going to deal now standard form 5. The equation is of the form x power mp, y power nq equal to 0. This m, the powers, the x power m and the y, it has the power n. This m and n, they are constants. So now x power mp, y power nq, this, it is transformed to such a equation f of capital P, Q, Z. That is the standard form 5. The standard form 5, it's nothing but here it is written, which is reduced to standard form 2. What is standard form 2? First, standard form 1. We have to see the equation. It should have only P and Q, the notation. If it is 2, it should have the notation P, Q and Z. If it is 3, it should have P, Q, X, Y. If it is 4, it should have P, Q, X, Y, Z. These, the given equations, if these are dominated, only PQ dominated 1, PQZ dominated 2, PQ, X, Y dominated 3, PQ, X, Y, Z, 5 are dominated, it is 4. What about, now if you are noticing these 4 forms, X and Y, they are not having any powers. But in standard form 5, X and Y will be having the powers. That is the difference between standard form 5 and the previous standard forms, the 4 forms. In the 4 forms, X and Y will be having the power. Only X and Y will be. Whereas standard form 5, X will be having the power 2, 3, or n will be having the power -2, -1. The powers will be there, which differentiates the standard form 5 from other 4 forms. Yeah, coming to the picture, now standard form 5. So the standard form 5 is there. We are going to reduce into standard form 3. The given question, we will be noticing m, that is this x power m. M is playing what is the value of it. If it is not equal to 1, and y the power is also n, the n value also, if it is not equal to 1, then we have to take capital X equal to small x power 1 minus m. Then capital Y equal to y power 1 minus n we have to take. Case 2. Suppose this m equal to 1, n equal to 1. If it is the question xp plus yq. Now x power is, here the place is what? M. And it should be xp form. That is also very, very important. X into p it should be. Y into q it should be. That is standard form 5. If this m and n, if their values are equal to 1, then we have to assume capital X equal to log x, capital Y equal to log y. So the two cases will arise when which is not equal to 1, the powers m and n. If they are equal to 1, we will assume the case 2 case. So this is our given question. The given question, first taking totally 6 standard forms are there. The first standard form, it is there or not, we have to see. Because every standard form, it has its own way of solving the equations. First, our prior duty, the given is standard form 1 or not. 1 means compulsory, it should have only P and Q. So it is vanished, it is not a standard form 1. Standard form 2 means PQZ. That is also vanished because strictly in the standard form 2, X and Y should not be there at all. Vanished. P, Q, X, Y. This is standard form 3. In this, Z compulsory, it should not be. So that is also vanished. Within a fraction of a second, we should take the decision. Just a fraction, we will overall once 1, 2, 3 and 4 P, Q, X, Y, Z all should be there. Yeah, everything it is there, but it is not a standard form 4. Why? What is the reason? Because standard form 4 P, Q, X, Y, Z, it has its own way, but here this given question x square by p is there. We know it exponential law. 1 by a power m means we can write a power minus m we can write. Similarly now this x square by p can be written as x square p power minus 1 we can write it. So x into p the combination, and x also should have some power. Then it comes under standard form 5. Similarly now y square by q is there. That y square by q, that is also to be written y square q power minus 1. So the given equation is, so this is the given equation. So x square, so the p, the up it is coming, satisfying the exponential law, it is written p power minus 1. And y square it is written as it is. The q it has come up. So q power minus 1, here z is written. This is our standard form 5 notation, compulsory notation. So this we are writing as equation 1. But the previous step, if you are noticing, x square p power minus 1 is there. But here we did some simplification, some changes we did. Is that necessary? We have to do these changes. Why? Without doing these changes, the previous step equation only, we can name it as 1. Why we didn't do? What is the reason? What is the purpose of changing this? These changes are why. It is must we have to do it. Because the standard form 5 condition is x power m into p. That means the p should have the power plus 1. Y can be any power into q. Q should have the power plus 1. In the previous step, if you are noticing, p is having the power minus 1. Here, q is having the power minus 1. It is not possible according to the standard form 5. That is the reason this x square p power minus 1 be simplified in such a way to satisfy the standard form 5. How we have done it? X power minus 2 p and minus 1 we kept it out. So minus 2 into minus 1. Minus 2 into minus 1, we are getting x square. P into minus 1, we are getting p power minus 1. So the simplification is correct. Because if you are doing the next step, the previous one is coming. So we are doing mathematically, it is a correct simplifications. We followed it. Now here also, y square q minus 1 is there. We have done it y minus 2 q. This minus 1 we have taken out. If it is correct or not, we can check it. Minus 2 into minus 1, we got it 2. Here plus 1 is a plus 1 into minus 1, minus 1. This simplification, it is must to satisfy our standard form 5 form. So the equation, the above equation comes under standard form 5. That is f of x power m into p, comma, y power n into q equal to 0. The same equation which is kept here. Now, we are noticing our form, standard form is x power m p, y power n q. This is only our form. So, x what power it has? That is m. N what is having? That is the y what it has. Now, m place minus 2 is there. N place minus 2 is there. For us, standard form 5, to solve, two conditions are there. If m and n not equal to 1, one condition. If they are equal to 1, one condition. Ours is, our given problem, m equal to, we got it minus 2, n equal to minus 2, we got it. So it falls under the case m is not equal to 1 and n is not equal to 1. According to that case, capital X equal to x power 1 minus m. So x equal to x power 1 minus this m place we are substituting minus 2. So we are getting x cube. Similarly now, y place 1 minus n is minus 2. We are substituting, we are getting y cube. So we can notice it here. So m equal to minus 2 and n equal to minus 2. Fine. So capital X equal to, this is the step to be followed if m and n, they are not equal to 1. So capital X equal to x cube, capital Y equal to y cube. Now how to proceed? Now these are the steps to be followed for the case m is not equal to 1 and n is not equal to 1. We know the notation small p equal to dou z by dou x. But now one new term which is introduced, that is capital X equal to small x cube. This capital X should be given connectivity to this dou z by dou x. How to be inserted this capital X here? A very simple way we inserted, that is dou z by dou capital X into dou capital X by dou x. If you cross it, the balance we are getting the previous one. So mathematically it is correct. So now we will do the differentiation. The first one is dou z. The notations, it's very important one. Small p, the notation is dou z by dou x. Now we got it dou z by dou capital X, we got it this particular place. Now this particular place we got it dou z by dou capital X, it is there. Then this notation we will give capital P. So small p equal to capital P, and this we will do the differentiation. That is dou x we have to do with respect to x partially. That means we are going to do concentrate or favor. We are going to do with respect to x. Simple thing. We know the formula x power n. That is n x power n minus 1. So x cube, n is playing the role 3. So 3x 3 minus 1, which is equal to 3x square. Again x differentiation is 1. So we got it. 3x square is the answer. We got it. So we can notice it here. So small p equal to capital P into 3x square. Just we brought the x square towards the left side. So small p by x square equal to 3p. Why we are not even we brought only the x square towards the left side, but even we can take this 3 also to the next side, but we didn't do, because to consume the time we have to come to a conclusion to reach the solution. That is only our main target, keeping in our mind what is our equation 1. The equation 1, if we are noticing, x power minus 2p is there. X power minus 2p, it's nothing but p by x square. So which gives an idea to us, better p by x square if it is there, that particular place, we can substitute this 3p. So the ideas are very important. So to replace here, we stopped only x square we brought to the left side. The p by x square equal to 3p. Now completely capital X equal to x cube. What are the steps? What are the treatments to be given for this? We completed. Similarly now capital Y equal to y cube, we have to do it. So this is very clear. Now capital Y equal to y cube. This is the notation. Small q equal to dou z by dou y. Now here the capital Y, it is there. That should be inserted here. That is dou z by dou capital Y into dou capital Y by dou y. We inserted correctly. Up and down it is there. what we inserted. So the balance we got the previous step. Now Q, the notation we know it, dou z by dou y. But here dou z by dou capital Y is there. That is the reason here we will introduce capital Q into dou capital Y by dou Y. That is, here this we have to do the differentiation partially. If dou is there, the word partially, it is compulsory. So dou Y by dou Y. So now Y, capital Y equal to Y cube. The formula n into x power n minus 1. So we will apply 3y 3 minus 1 into y differentiation is 1. So we are getting 3y square. So small q equal to capital Q into 3y square. Now this is capital Q. This is 3y square. We brought it this y square down. So it is becoming q by y square, which is equal to 3q. Already we got p by x square, which is equal to 3 capital P we got, the previous one. Now we got it this one. So this is a q by y square equal to 3q. The y square, the exponential law satisfying. 1 by y square, it is written y power minus 2. Because 1 by a power m equal to a power minus m. This law satisfying, which is written here. Now this is our equation 1. This is nothing but we got it 3 capital P. This we got it just now, that is 3 capital Q, which is equal to Z. So completely. Now after doing all these steps, our standard form 5, we got it. Now if we notice this equation, the obtained, the current equation which has capital P, capital Q and Z, there is no x and y terms. So completely x and y terms are eliminated. We got it only P, Q, Z. It's nothing but our standard form 2. So from the standard form 5 2, we reduced to standard form 2, we got it. This standard form 2, how to solve? Solving the standard form 2, some specific methods are there that we have to adopt it. Now this is the standard form 2. So this comes under standard form 2, that is f of capital P, capital Q, Z equal to 0. This is the procedure of standard form 2, that is Z equal to f of u, where u equal to capital X plus a capital Y, and we should assume capital P, it's nothing but dz by du. Capital Q, it's nothing but a into dz by du. And these two should be substituted in our, the current recently what we got it, that equation we have to substitute. That is this equation. After substituting, we have to solve P and Q, and we have to do integration, and we will get the required solution. Yeah, we will do it now. So this is 3p power minus 1. A power minus 1, it's nothing but 1 by a power m. So following this, 3p power minus 1, which is written 1 by 3p. Similarly, 3q power minus 1, which is written 1 by 3q, which is equal to z. Now, the p to be replaced by this value, that is dz by du. So 1 by 3 into dz by du, that is the reason it is coming up du. We can notice it here, plus 1 by 3 q. Q should be replaced by a dz by du. So a dz by du. In these two terms, if you notice, du into 3dz, which is common, so completely it has come out. 1 it is there and plus it is there. The balance is 1 by a, which is put here, and z is written as it is. So now we are z and all we are grouping in one place to do the integration to make comfortable. So dz and z, we are going to group it one side. The remaining terms we are grouping into another side. So just in this step 3 we brought it to next side. Now integration we are doing. This is with respect to u, we have to do it. This completely, this is constant. So better we can keep it out before the integral. Du. The du integral, it's nothing but we know it very well. 1 plus 1 by of, this is u we are getting. Whereas this is coming to the picture. Here 3 also we can keep it front. Z dz we are going to get. The integral formula is x power n dx. X power n dx, it's nothing but x power n plus 1 by n plus 1. So z power is 1 here. That means n is playing the role 1. So 3 into z square by 2. So we did the integration. So du u, it is written as it is. 3 is written as it is. Z square by 2 plus c. Now the standard form, 5 short form I am writing. That is f of x power m p y power n q equal to 0. Thus, we reduced into standard form 3, that is f of capital P, Q, Z equal to 0. Standard form 2, we reduced it. According to standard form 2, we have to take P equal to dz by du and Q equal to, we have to assume P and Q some terms, and we have to do, after substituting integration we have to do it. Initially we assumed f of z equal to u, where u equal to x plus a y. So finally the u is replaced by x plus a capital Y equal to 3z square by 2 plus c. We will come to a conclusion that what is partial differential equations we discussed. That is the equation which has partial derivatives. Compulsory the symbol the representation of partial differential equation, the dou symbol, and it should have at least one dependent variable, that is our z, two independent variables, x and y. In detail we discussed. And what is non-linear partial differential equation? That is dou z by dou x. This is first order linear equation, but dou z by dou x the whole square, this is first order but non-linear because the degree is 2. And we have taken one problem and we tested standard form 1, 2, 3, 4, and we coming to the picture. This is the formation of standard form 5, that is f of x power m p y power n q equal to 0. Some steps are fall out and it is reduced to standard form 2. Standard form 2 strictly it doesn't contain x and y. Such a formation we got it. According to the standard form 2, we substituted p and q assuming some value and we did the integration. So this is the standard form 5. It is reduced to standard form 2 and z equal to f of u, u equal to capital X plus a capital Y. The p it has taken dz by du, q it has taken a into dz du, that we substituted in our standard form 3, that is standard form 5 2. We have come to standard form 3. In the standard form 2, that we substituted these values and we did the integration and we got the required result. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.